Okay, let's see a variation of the problem we had before. Okay, I have two shuttles, two Cartesian planes. Okay, so two different objects. And what I want to do is somehow coordinate these two shuttles. Okay, and the coordination I have is, maybe it's a little silly, but what it's doing is it's making sure that when one shuttle is going along the y-axis, the other shuttle, so we're going to we're going to start both animations at the same time, okay? But we want some synchronization between them. And we're going to make sure that when one shuttle is going along the y-axis, the other shuttle cannot also be going along the y-axis. So imagine I'm a user, I can only see one thing going at a time, and I'm really interested in the liftoff, not going in the x direction. So I want to go and serialize the execution of these two shuttles in this way. So I want some coordination, and let's just see what happens. I start the shuttle, nothing happens. I start another shuttle, nothing happens, animation. Now I say proceed, and one shuttle goes up along the y-axis. As soon as it goes and releases the y-axis, it starts going the x-axis, the other shuttle proceeds. Okay? So I have some coordination going on here. Okay? This is going back to, we saw such coordination when we did synchronized methods. Okay? And there was some weighting there. We've seen some weighting with sleep. So how do you think I implemented this? How did I make one of these shuttles wait till the other shuttle had taken some action? Zach?
Did you have to synchronize the loop for the y?
So could I have synchronized the loop for the y? Okay? Somehow have that in one method, and then whoever enters that loop first would grab it, and then the other one would go and get it as soon as that loop is released. Okay, you guys like the idea? So we had, actually, so I don't remember how my methods went, but I think I had a separate method for going along the y-axis and a separate method for going along the x-axis. Even if I don't, I can do that. I can make the y-axis method synchronized and then serialized execution. Okay, you guys like this answer? You already have seen synchronized methods. I'm just applying synchronized methods to this problem. Synchronized methods were done 2 slide decks ago. I've just started a new slide deck. That can't be the right answer. So when I have a synchronized method in an object, and I have in a class, and I create 2 instances of that class, does each instance have its own queue, or is there a common queue for the whole class? You guys remember?
Each instance has its own queue.
Each instance has its own queue. And what I have here is actually 2 different shuttle animations. I have one shuttle object, another shuttle object, one Cartesian plane, another Cartesian plane. Okay? So I can't quite have done this. Okay? And also notice, when I went and said proceed, when I first executed animate from shuttle, both of these shuttles were waiting. They didn't start till I did proceed. If there was a synchronized method, and that queue is, even if we had one object, if that queue is empty, the first guy would go. So somehow, this shuttle waited for my proceed button, so did this shuttle, and then when this shuttle started, the second shuttle waited for it to release the y-axis. So the synchronized method, thinking along the synchronized method is the right thing. That's a way to make things wait. Synchronized method is a very simplistic way of making things wait. It works many times, in many situations. I've concocted a situation where it won't work, to illustrate that we need something more complex. Okay? So we can't use synchronized method, but we can program. Can we somehow program this ourselves, knowing about Java that we do, what we know about Java? Or could we use something else? Could we sort of ask Java to give us something that we don't? If we can't do it, then we need to ask Java for something else. So how could we have we seen anything to make a program wait ourselves before? Sleep. So could we go and somehow have both of these? When I went and started each one of them, they could be sleeping. And then when would they unsleep? Something woke them up. So somehow we want to, so we don't want to say sleep for 100. We want to say sleep until somebody wakes me up. That's what we want. Okay? So let's see what I have here. So how does the thread wait for an and what we want to do is, so this is what I could have done. I guess this is let's see what I've got here. I've forgotten what I have here. So so the question here is, does the synchronized method work or not? Okay, that's the question I'm trying to answer here. Okay, and synchronized method doesn't work for two reasons. One of them was that we have two different objects. The other is that we had to wait till the user presses a button. Okay, so if two methods execute the same method, one of them will wait, and this is the one that's waiting because this particular thread is executing it. And we are waiting here. We do wait here, but we are waiting for some previous event that we didn't even expect to finish before we execute. Okay, that's what synchronized method gives us. Okay, so we want to, on the other hand, in our case, we want to wait for some future event. The user presses proceed before executing. So it's not as if we are waiting for some previous event that we didn't even expect, but that happened. Okay, we are going on an intersection, and somebody came to the stop sign before us, so we have to wait. Okay, here I'll show you the analogy. It's more like a relay race where I'm waiting for somebody to go and pass me the baton, and so that I can go further. Okay, so I could do sleep, and I could do that. And the way I could do this is that I could continuously go and sleep for a second, check some Boolean to see whether I can proceed, sleep for a second, do check again, and that's kind of called polling. That's called polling. Okay, so you don't want to poll. You don't want to continuously wait. A lot of times you have to do this because we don't have anything better, but we certainly don't want to do this if we have something better. Okay? So it wastes CPU time, and we really need to wait for a signal produced by some other thread. Okay? So we want to sleep, and and the analogy is here. Okay, analogies are here. That in all of these cases, here there is somebody who's driving. Here's somebody who's waiting to start a race, and here is somebody else who's waiting to continue the race. So somebody's waiting, and somebody else signals, and these somebodies are threads. Okay, here so the policeman signals, okay, you guys can go. So you start proceeding. You fire the gun, and the race starts, and the baton is passed. Okay, so what we have here is what we need. So look at the relay race. When this person who's passing the baton says to this person who's waiting, proceed. So this person is waiting for proceed. They're waiting for their position till this person goes around the track and says, okay, now you can go. Okay, so that's what we want. This is the kind of signaling we want. Something, if you ever run a race, if you've ever gone on a road, you know how to go and follow this protocol. So this protocol I'm telling you is a big step in computer science, but it is not a big step in common life. Okay, and so that's all you really need to know for this particular slide deck. Okay, that there is a notion of where we had sleep, we are going to do some kind of wait, which is we're calling wait for proceed here, where we didn't have any way of waking up somebody. That wake up is this proceed. Okay? Yeah, Marcos.
So in that sense, are you telling the program just to wait for an interval and then to routine for that interval?
Ha. So, you're wondering how this is executed, right?
Right.
And I kind of told you earlier that we could execute this using sleep. That I could go and sleep for 1 millisecond, 100 milliseconds, a second, and then go and check something, and so forth.
Right.
And if I'm going to get the event in 10 hours, how many times did I go and check that? Okay. So that's a one way to implement wait for proceed.
Yeah, but it seems like it's the opposite of the other one.
And think about how sleep was implemented in the first place. When you said sleep, what did the system do? What do you think it did? Yeah.
And suspend all threads for a certain amount of time.
It suspended that thread for a certain amount of time. And when you suspend it, what do you really do? So when you're ready for execution, and there are 5 threads, okay, they're all ready for execution. What happens to those threads? They get put in something called a ready queue. Okay? And the CPU says, okay, who's at the front of the ready queue now? Let me execute you for 100 milliseconds. Now, enough with you. Let me go to the next thread, execute you. And so the person who was in the front of the ready queue goes to the back of the queue after they've executed. So there's a queue of waiting threads, okay, of ready threads. When you go to sleep, you get put in a sleep queue, okay? And that sleep queue is ordered by the time at which you have to wake up. So if you ever go to a hotel, what do they do when they don't have an automatic system? They go and sort you and put you in a queue, and then they go and say, oh, who's the 6 o'clock person? Let's wake them up, remove them from the queue. Who's the 6:30 person? They go and wake them up. That's what the OS is doing. Okay, it's putting you in a queue, and it counts time, and then it goes and says, okay, it keeps these things called deltas, and it says this person's deltas seconds behind this person, and it just counts time. Okay? So how do you think what do you think is going to happen here? When you said wait for proceed and a thread, what happened to you? You were in the ready queue, you became current, you were executing. At this point, you have to be suspended. And where would you go?
So the waiting queue?
A waiting queue.
But would you go to the waiting queue without a determined amount of time, and then when that proceeding happens, it calls you?
When the proceed happens, the proceed is associated with that queue. And the operating system says, I know that this one is proceeding. So it goes and says, who's the first one waiting? You execute. That's it. This is operating systems in a nutshell. Okay? Okay? And let's go and see how wait for proceed is actually not provided by Java. It's something we wrote. So let's go and see what's going to happen. My shuttle animation thread is going to call wait for proceed. Okay, this is what we want to happen. And who's going to call the proceed? This is a thread. When it calls wait for proceed, it's going to block. And who's going to call note proceed now? In the traffic cop, there was a cop and there was a driver. And the proceed is going to be called when I press the proceed button. When I hit the proceed button, which thread is going to be calling it? Okay. So basically, our AW thread is the one that's going to call proceed, and our shuttle animation thread is the one that's going to wait. Okay. So we understand how these two methods are going to be used, and now the question is, how are they implemented? And here's how they're implemented. Okay. So this is I guess in the previous slide I had that. I've created a class called a clearance manager, which has got this method proceed and wait for proceed. Okay. And the reason why this proceed button is being displayed is because I said object editor.edit clearance manager. Okay. And a feature that you don't know about object editor is that not only can you invoke methods from a menu, but you can also invoke methods from buttons. Okay. And the reason why this button is displayed, this method proceed method has got a button for it is because I said it is row 0. I mean, that's just a detail I don't want to get into, but that's the reason why I've got it's there. It's on. You can have row 0, column 1, and so forth. So you can create a nice panel using object editor or buttons. Okay, so that's the part here, which is not the interesting part. The interesting part is that my AWT thread is going to call the proceed method, and my animation thread is going to call the wait for proceed, and these methods do what is being shown here. Okay. So what's unusual about the methods I have here? This is a very small piece of code. What's confusing about this? What is it that I need to tell you more to understand how these things work? What does the wait function do? Okay. Now, firstly, my clearance manager is inheriting from object. The wait function is not here. So where do you think the wait came from? So you might have noticed that object actually has a wait method. And where did the notify come from? Okay. So now at least we know where they came from. And what do you think the wait does? Exactly what I explained in the previous slide. It puts the method it puts a thread that called wait in a queue. Okay, in a queue associated with this object. So this object has not only a queue for synchronized methods. That's one queue. That's a synchronized queue. It also has a queue for waiting. Two different queues. Okay. And okay, now, so you understand there's a synchronized queue and there's a wait queue. Now, why do you think and so what will notify do? It'll go and say, please, if anybody in my wait queue is waiting, please make them eligible to execute. Okay, so notify, you'll call proceed, you'll come back, you release the clearance manager. Okay, and so there can only one, because these methods are synchronized, there can be only one of proceed or wait for proceed happen at one time. Let's try to figure out why we've got that semantics. And also to indicate, also I want to specify that we have these two different queues. So why now did we make these methods synchronized, do you think? Okay, so what would go wrong if I did not make them synchronized? One thread could call wait for proceed, and another thread could be doing what simultaneously? Either calling this or calling this. What could go wrong if one thread is calling wait for proceed and another thread calls proceed at the same time? What's wait for proceed going to do? It's going to go and put that thread in a queue. Now, you guys have not, you guys can imagine how queues are implemented. It takes some time to put a thread in a queue. You've got to go and append to some list. You've got to change some pointer. That's not something that happens in one machine instruction. Okay? So while this particular thread is being put in a queue, so at the end of this method, when this method finishes, it's in the queue. Before the method starts, it's not in the queue. While the method is executing, it's somewhere in between. That queue is being changed. So what could go wrong if I call proceed at that point? That it's an inconsistent state. The invariants I talked about, preconditions, postconditions. So invariant is a postcondition that's also the precondition. The invariant of the queue is not established. It's in some funny state. That's why we had synchronized methods. We had synchronized methods to make sure that we do things atomically, so that if something is true before the method, the invariant will also be true after the method. And if we don't make it atomic, the postcondition has not been established. It's somewhere in between. Okay? So because there's a shared queue, the proceeds and the wait for proceeds should happen one after the other. It should not be the case that we allow them to occur. So if I actually go and do not make these synchronized methods, Java will complain and say, you cannot call wait or notify in a non-synchronized method. Okay? So that's one confusion I removed. There's a lot of confusion here. So what do you think this, so you guys have seen this try catch. I haven't quite told you exactly what it means, but we saw that these are a try in the very first day, I think, or first or second day. Whenever you're not certain about some instruction, some piece of code executing properly, you say, I'm not going to do this. I'm going to try doing it. And if I fail, then I will execute this catch block. And here I'm just printing the stack trace. I'm printing, and you guys have seen stack traces before, especially if object editor complained on you. So what do you think this kind of exception is? Interrupted exception. We've seen array index out of bounds exception, null pointer exception. What do you think this exception is? Zach?
Could it be that the current process is being interrupted? So in this case, putting the thread in the wait queue was interrupted.
So it could mean either that while you were putting it in the wait queue, you were interrupted, or it could mean either while you were putting into the either when you were being put into the queue or when you were actually waiting. Okay, and it really means that while you were waiting, somebody said interrupt. So you're not even doing anything, but it interrupted you, saying, and that's something you can do in Java. And so something bad happened, and at that point your waiting got interrupted. Okay, and so that's to catch that exception. Okay, so we understood this part. Now let's try to understand, is there anything else you guys need to understand? There's something really confusing here that I haven't told you. And that has to do with the fact that there are two queues. There is the wait queue and there's a synchronized queue. The wait queue you go into when you execute wait, right? The synchronized queue you go into when you're executing a synchronized method and somebody else tries to call a synchronized method. And I've got both queues here, so there's something confusing that I have to explain.
Like which waiting call happens first?
Okay, so which waiting call happens first? That's one issue. So let's say I go and wait. I'm a thread. I call wait for proceed. I get the synchronized queue, right? The lock. I don't get put in the queue. I get the lock, and I go and start waiting, and I get put in the wait queue. Now what happens? And so you're saying if another process goes and calls wait for proceed, what's going to happen? Another thread calls wait for proceed. What's going to happen to it now?
I'm not sure about that.
So what are some alternatives? So will that thread be able to execute wait for proceed? Will it be able to execute the wait instruction? And the question really is, when I executed wait for proceed, I got the lock on the object. When I as a thread did wait, did I keep the lock or did I release the synchronized lock? So if I did not release it, okay, did I release it? I don't know. I haven't told you.
Because like wait got called, so now it's not synchronized, so now you're able to call notify.
Okay, so if I did not release the wait lock, synchronized lock, how could anybody come into the room to go and wake me up? So I must have released my synchronized lock. So indeed. So what's going to happen? One thread calls wait for proceed. It starts waiting. Another thread, can it call wait for proceed now? It can, because the synchronized lock is gone, and it just goes and calls wait, and it gets put in the queue atomically. As soon as it's put in the queue, the method releases the lock and notifies that. Okay? Questions? I've got this in slow motion, but at least you get the basic idea here. So this is wait. inherited from object, notify, inherited from object. These are methods provided in all objects. Wait and notify implemented by object must be executed in synchronized methods as they access shared queue. Okay, we said, and wait releases synchronized lock on object. That's very important. Okay, makes calling thread wait and lets some other thread get object synchronized lock so that it can notify it. Yeah.
So these methods are stored in a clearance manager, and threads are.
Sorry, say that again. What is stored in a clearance manager?
Well, I mean, this code is in a clearance manager.
Yeah, a clearance manager is the one that has gone and provided these two methods. Yes.
Threads are calling them.
Threads are calling this, exactly.
How are the threads affected by these methods? They don't take parameters.
Threads don't take parameters?
No, the methods.
Oh, so why do I need a parameter here?
So that the clearance manager can actually put the thread in a queue.
Who puts it in the queue? Okay, firstly, there's one queue that's in this object. There's only one wait queue. There were languages before Java that had multiple queues. In fact, when Java was first invented, it had only one wait queue, and it just mind-boggling. I've never seen something like this. And Kevin Jaffe, who's another person who's interested in operating systems here, both of us talked to each other and said, is Gosling the most stupid guy in the world or the smartest guy in the world? Because he should have looked at the literature before him and seen that there were multiple queues, and here he has only one queue. And we looked at all the problems that were the classic problems, and the classic problems all work fine with one queue, actually. So he was really, really smart, we figured. There are problems you can't do, and you have to then deal with multiple objects. But all the classic problems that we taught were doable. So this was kind of brilliant, okay? Because it was new, and it was a simpler mechanism than the previous ones, and it seemed to do the same task, okay? Having said that, that queue is implicit, an implicit parameter of this object. So every object has its own synchronized queue and an own wait queue. So when you go and notify here, you're notifying implicitly the queue in this object. When you are waiting there, you're waiting on the queue on this object. And both threads, these threads did a wait on a particular clearance manager. Okay, so this is a clearance manager. The way proceed was done given the object as an argument. So you said object.proceed. So that object is the one that was chosen by both the waiter and the notifier. And maybe that's what you mean by the implicit parameter. So that object got created first. Both threads have access to that object. One thread did wait, the other thread did proceed. I will show you the code later, okay, and we'll see it all working. But do you kind of get it?
Yeah.
Okay, good. Other questions? So proceed is invoked by AWT thread, executing object editor code, okay? And wait to proceed is called by waiting shuttle animator thread. And both my object editor and this have a reference to this common object, which is how they're accessing the same queue. Okay, so let's go and see in great depth what's happening. The shuttle animation thread somehow chooses a particular instance of the clearance manager. It has that, it knows about that. And it goes and calls wait for proceed. It gets a lock on the object. Okay? So because this is a synchronized method, it gets this lock, and at this point, no other synchronized method can be executed in the clearance manager. Okay? That does a wait in the superclass. Okay? This is a final method, so you can't really override it. And at this point, what happens to this lock? So this thread waits, and at this point, the lock is released. Okay? So now you go and, that's exactly what I'm saying here. Now this particular user says proceed. The proceed method is executed. It gets the lock. So if anybody else tries to do a wait at this point, while it's changing the variable queue here, they'll have to be queued in the synchronized queue. So this goes and calls the notify method, which will do what at this point? What will notify do? So it'll go and make this no longer waiting. But will this guy execute the wait immediately? Will it execute, will it go and, so there's an instruction after wait. Will this particular thread execute that instruction after the wait immediately? No, because it's got this lock. Only one thread can be executing that code at any one time. So it releases the lock, and now this guy goes back and does the instruction after that. There is no instruction. It just returns. So it gets back the lock, it executes the next instruction, and it's over. Okay? And the lock is released. Okay? Questions? So wait and notify methods, just as there are these three other methods like toString that you've seen, equals, there's wait and notify in there. Okay? And I'm just saying in text what I've said many times. And now let's just go and see how this all works out. So my shuttle animator now, in its constructor, you were talking of constructors, Fred. So in my shuttle animator now goes and has a clearance manager as an instance variable. And my animate y from origin, which was my the one that was doing the animation. This is a subclass of my previous one, and this particular animate y from origin, before it calls the superclass method, goes and calls wait for proceed on the clearance manager. So the threads call methods that call other methods. So whoever's calling my animate from y from origin does clearance manager dot wait for proceed, and this clearance manager was passed as an object to my shuttle animator waiting for clearance. Okay? So I had a shuttle animator that was just doing animations without clearance. Now it's waiting for clearance, so it gets a clearance manager and does a wait for proceed. And both of these particular shuttle animators have the same clearance manager. So since they're the same clearance manager, they're waiting on the same clearance wait for proceed. So this is where the wait happens. Okay? So that's what's changed. And my main, what does it do? It displays the shuttle animator. It displays the clearance manager. So there's just some object editor dot edit calls here to go and make the frames appear too. And here's the interesting thing. I create one clearance manager. That's the same clearance manager that I go and display on the screen. Okay? And that's the same clearance. I think I have some animation here. So this is the clearance manager that I pass here, that I go and that I display, and that I use for the other guy. So there are three agents there. There are three UIs there. One shuttle UI, another shuttle UI, and the object editor clearance manager UI. All three UIs, all the objects involved in all three UIs use the same clearance manager, so that we're all waiting on the same queue and not different queues, because every object has its own wait queue and synchronize queue. Okay. Okay. So this is the this is the basic picture. Any questions here? The basic concept was this wait and no. And okay, so let's make things even more interesting. I have this proceed all. Anyone want to guess what this proceed all is going to do now? Yeah. Sorry? So it's basically it makes both of these shuttles start at the same time, so that they can have a little race. Okay. So they're both waiting, and I say proceed all, and they start simultaneously. Okay, and these are two different objects. I didn't do this by any synchronized method because these guys had to wait, and so I've got now another kind of notification. So previously, When a proceed happened, it called notify. Notify went and woke up the first thread waiting on a queue. And what kind of notify do I want now? Notify. And what would that do? This analogy here. So if this is wait for proceed, this is proceed. And these two guys are doing what? Proceed all, right? When the cop says that, you know, you can all go, everybody goes. And when he fires the gun, everybody goes, and it's not just one person. Okay? So again, in real life, we do this kind of coordination, and it's a big step for computer science just because we've gone and added this real life stuff into our program. Peter?
When you proceed all, does it proceed in order, or is it like exactly?
So when I say proceed all, I'm saying all you guys in the waiting queue, you go from the waiting queue to where? I mentioned another queue earlier in the class. The ready queue. So you're saying, I am making you guys who are ineligible to execute now eligible to execute. I'll put you in the ready queue, and now it's up to the scheduler to figure out which one to execute at what time. Okay, so what would happen? How did the two shuttles go together? Remember, then one of the thread executes, and it goes and says, I want to sleep. So it goes into the sleep queue. So now the CPU says, the operating system says, oh, he can't execute, so let me go and pick up somebody else from the ready queue, execute them. They go into the sleep queue, and then they get released from the sleep queue, put in the ready queue, and then execute. Okay? So that's the classic round-robin execution of threads that you've seen. When you start multiple threads together, you know what happens. That if there's only one core, one CPU, only one will execute at one time, and there is this round-robin servicing of the ready queue. Okay? Other questions? So here we had one person proceeding, one thread proceeding. Here we have everyone proceeding. Okay? And what did I do here? I didn't do anything great. I just made sure that my button here appears on the next row. And I called notify all. Notify all is also a method defined in class object. So class object has got wait, notify, and notify all. And you have to go and call these methods in synchronized methods. That's why I went and created another method called proceed all that goes and calls notify all. Okay? So nothing difficult. So now you know pretty much everything needed to do your next assignment with these concepts, except for generics, which I'll. Okay? So notify is this another method here. Okay, and here's just some code that goes and makes this all happen. And the only difference is, let me see if I have some. The only difference is that where I had a clearance manager, now I have a broadcasting clearance manager, and that broadcasting clearance manager has this proceed all but method added to it. That's the only difference here. Otherwise, okay. So what I had previously was some kind of traffic control, right, with the shuttles. And there was manual traffic control. That I, as a user, was saying proceed all, and so forth. Okay? And wouldn't it be nice if the coordination was done? So all the proceeds were done by the user. Okay? Were triggered by the user. The user pressed the proceed button, which went and called the proceed method, which went and called the notify method. It's also possible for the objects to sort of coordinate themselves without any interactive user being involved. Okay? So what I'm going to show you here is an example of that, just to show you that not everything goes through proceed all, through a user. And here's an example of something here that we're going to start 3 shuttles. There's no proceed from the user. The first shuttle started immediately. As soon as it releases the y-axis, another shuttle goes. And as soon as it releases it, another shuttle goes. Okay? So we are not having the end user go and say proceed, but somehow these particular threads are coordinating with each other, and the first thread just went, and the other threads didn't, waited. Okay? And how do you think I did this? What's the difference between this and the previous ones we've seen before? I mean, what? Yeah.
There's like a wide loop, and then after that, just and notify somehow.
Okay. So previously, a shuttle waited before it did the while loop. Now the shuttle is going to wait before it does the while loop, and it's going to do what? Notify after. You see a lot of this stuff happen. It's not that the end user is going to do this, but the same guy first does a wait, says, I want a lock, and then it goes and releases the lock. Okay? And the analogy I like to give is, let's say I need only one room. Okay? And in that case, we can have the synchronized methods here for each of the doors. Okay? What if I need 5 rooms to do my, do a play of some kind, or do the lecture here and do a remote presentation there? There's an overflow. Okay? I can't use those semantics of per room, so I need to go and lock multiple things at the same time. And so I need to, just like synchronized method, I need to go and reserve something before the activity. But now I can't rely on what Java has given me, so I've got to do some kind of wait on a central object. And then after I finish doing my task, I've got to do a notify on that central object, which is a central object that everybody will go through to get these rooms. So we're doing a conference rather than a class. And every time you do a conference, you go and say, can I get all the rooms in the conference? So you go to some conference object that will give you the lock. So this is what kind of is going to happen. So a separate y-axis, so cannot synchronize on it. And this is sort of going back to what Zach had said earlier, that we can't quite use the synchronized method. So we need to build our own synchronization scheme, and we have multiple objects involved, so we can't rely on one particular object. So we're going to go and have this lock object. Okay, that's like my clearance manager, except that we have this boolean called locked, and the first guy should not wait, right? So we go and check the boolean value, and we go and say, if I'm locked, then I wait, otherwise I don't wait. So the first guy will not wait, and after I have gone and got the lock, I go and say lock to true, okay? And then the release lock will go and just notify. And Keenan, if you remember way back when we were trying to motivate synchronized methods, you wanted to implement something like this. You cannot implement something like this unless you have synchronized methods, because my lock variable is a shared resource. So the synchronized method is essentially doing this in the operating system, and we are really building something like this with synchronized methods. So this is a lock. This is something that you use a lot in computer science, and we see now how a lock is really implemented. Okay, and now all of my any questions about this before I go further? So before doing an activity, I will do a get lock, and after that, I'll do a release lock. And this is what's happening, that before I do the animate from origin, I do a get lock, and afterwards I do a release lock. Okay, which is doing my notify essentially. Okay, so now I don't get to my clearance manager as an argument. I get a lock. Okay, so in your next assignment, I think as extra credit, I have some exercise that will require you to do notify yourself rather than just rely on the clearance manager doing it. So the clearance manager object that I showed you, please use that in the next assignment. Okay, as it is. Just copy the code or go to my. Okay, and this is just my my main code. This has got a method here that's called 3 times, one for each shuttle that has a lock as an argument. So the same lock they all use. This just goes and displays the right thing. And the interesting thing really here is that around and it's the same lock. Okay, so we have to make sure that we use the same lock, otherwise we won't be synchronized. Okay, so that's the only challenge here. Okay, questions? And this is just